Have you heard about wastewater sampling and dissolved oxygen analysis? If you haven't, come, let's learn with us. To be able to breathe is a privilege that we oftenly took for granted. But the reality is not what you see here. The news you haven't heard is the Mother Nature is sick, and water pollution is one of the issues. Water pollution happens when toxic substances enter water bodies, such as lakes, rivers, seas, and oceans, dissolving them, lying suspended in the water, or depositing on the bed. Water pollution can be caused in a number of ways, but one of the most polluting is city sewage and industrial waste discharge. Sewage is the term used for wastewater that often contains feces, urine, and laundry waste. Did you know that untreated sewage water can contaminate the environment? Next, thousands of different organic chemicals can become water pollutants if it is accidentally released into the environment. Example of these water pollutants is pesticide and herbicide. Next is urban garbage. Garbage often ends up in these surface waters. In urban areas, garbage are illegally dumped directly into a water body. Regardless of source or type, trash is a form of water pollution. This is the reality that we chose not to see: raw sewage, organic chemicals, and urban garbage. Next, the sources of water pollution is heavy metals, radioactivity, and sediment. Heavy metals can enter a water supply by industrial or even from acidic rain, breaking down soils and releasing heavy metals into streams, lakes, rivers, and groundwater. This radioactivity are contamination by nuclear power industry, military, and natural sources. Sediment is the only water contaminant that exists throughout all stream basins. Within a few hours, a single small construction site can contaminate entire receiving streams and lakes. This is the proof that heavy metals, radioactivity, and sediment is the source of water pollution.
Okay, let's move on to how water sampling is conducted. The flowchart shows the step of water sampling, which is first, sampling planning, second, water sampling preparation, third, sampling at the site, fourth, transportation, and then for the last step is analysis before it going to the storage. Okay, now we're moving on to water sampling procedure. First, if sampling a body of running water, point the mouth of the pipe upstream and our hands downstream to avoid contamination. Second, if sampling from a water faucet, run the faucet for 1 minute before obtaining a sample. Third, rinse the bed twice with the sample water prior to filling and closing. Fourth, fill bag as full as possible. Half filling the bottle leaves more room for oxygen, which will promote degradation of our sample. Fifth, collect data such as temperature and pH, which affect the solubility of many ions. There are 5 types of sampling methods, which is first, systematic, second, random, third, judgmental, fourth, stratified, and fifth, haphazard. So, what is systematic sampling? Systematic sampling, where points are selected at regular and even intervals, is statistically unbiased, providing the coordinates of the first sampling point are determined by random numbers. Systematic sampling does not generate clusters of sampling points, and it is easier to use to survey sampling locations than random sampling. A square frit is the commonest type of systematic sampling pattern. Second is random sampling. With random sampling, sampling points are selected random but not arbitrarily. A legitimate random number generator should be used to determine sampling point coordinate. Most scientific calculators can generate numbers that are sufficient random for the intended purpose. The randomization process ensures any location within the sampling area has an equal chances of being selected as a sampling point by chance can cluster together. This makes them efficient for detecting hotspots and for giving an overall picture of the spatial distribution of the contaminated site investigations. Thirdly, judgmental sampling. For this method, sampling points are selected on the basis of the investigator's knowledge of the probable distribution of contaminations at the site. It is an efficient sampling method which makes use of the site history and field observations but have this advantage of being potentially biased. The quality of the sampling results depends on the experience of the investigator and the available site history information. Judgmental sampling should not be used in validation sampling. Fourth, stratified sampling. First, divide the site into sub-areas according to geological and geographical features, nature of the contamination, former usage pattern of the site, intended future use of sub-area, and other relevant factors. Each sub-area can then be treated as an individual site and different sampling patterns and sampling densities apply. A stratified sampling pattern approach is the best suited to investigations of large sites with complex contaminant distributions. This sampling pattern may require a more complex statistical analysis, and it is not considered further here. The last one is haphazard sampling. A haphazard sampling is a sampling location or sampling time is chosen arbitrarily. This type of sampling is reasonable for a homogeneous system. Since the most environmental systems have significant spatial or temporal variability, haphazard sampling often leads to biased results. However, this approach may be used as a preliminary screening technique to identify a possible problem before a full-scale sampling is done. Type of samples. Grab sample. A grab sample is a discrete sample which is collected at a specific location at a certain point in time. If the environmental medium varies spatially or temporally, then a grab sample is not representative and more samples need to be collected. Composite sample. A composite sample is made up by thoroughly mixing several grab samples. The whole composite may be measured or a random sample from the composite may be withdrawn and measured.
So now I will proceed with how to analyze dissolved oxygen. So basically, dissolved oxygen is the amount of gaseous oxygen dissolved in the water. Oxygen enters the water by direct absorption from the atmosphere by rapid movement, or as a waste product of plant photosynthesis. Water temperature and the volume of moving water can affect dissolved oxygen levels. Dissolved oxygen is important for good water quality and necessary to all forms of life. So now, how dissolved oxygen is analyzed? The method for analyzing dissolved oxygen is titration method. This is also known as Wickler's method. The Wickler method is a technique used to measure dissolved oxygen in freshwater systems. Dissolved oxygen is used as an indicator of the health of a water body, where higher dissolved oxygen concentration are correlated with higher productivity and little pollution. This test is performed on-site, as delays between sample collection and testing may result in an alteration in oxygen content. So, what we have to know about Wickler's method is, this is the procedure. Add a manganese peroxide solution and a sodium hydroxide solution to sample water, and a precipitate of manganese hydroxide will be produced. This precipitate of manganese hydroxide reacts with dissolved oxygen in the water and is oxidized according to the amount of dissolved oxygen, forming a brown precipitate. So, if dissolved oxygen is not present, white precipitate will observe, and if it reacts with dissolved oxygen, brown precipitate will observe. So dissolve this brown precipitate in an acid in the presence of iodine ions, and iodine will be released according to the amount of dissolved oxygen. Then titrate the released iodine with sodium thiosulfate and determine the quantity. As we can see, this is the chemical reaction of the Wickler's method will be observed.
Now I'm going to talk about how to mitigate water pollution, what we can do as an individual to make a change. The first step is conserve water. Turn off the tap when running water is not necessary, such as when you brush your teeth, and fix leaky taps around your house to avoid more water loss. By conserving water, we can prevent water shortage and reduce the amount of contaminated water that needs treatment. Next, manage your waste properly. Do not throw oil, paint, or other form of litter down the drain. Use environmental-friendly household products and toiletries. They are a lot safer and healthier for our planet. Do not overuse pesticide and fertilizer on your plant. Overusing pesticide and fertilizer will cause the material to run off into nearby water source, and it will cause water pollution such as eutrophication. We can also prevent it by planting more plants that will help to absorb excessive pesticide and fertilizer. Last but not least, do not litter. Not only it is hideous to look at, but it will also contaminate our river, lakes, and ocean. Littering is never a good thing to begin with. So wherever you are, do not litter, please. Instead, let us help to clean up any litter you see. Make sure it is safe to collect them and put it in a nearby dustbin. That's all from us. Hope that you learned something from this video, and remember, together we can make a change.